At Ncert Video Books welcomes you. In this channel, you will see explanation and solution of Ncert books. For this, you have to visit the channel, then go to playlist and see the chapter. Today we will be studying textbook of mathematics for grade 5, Maths MELA. This book has 15 chapters. Today we will be studying Chapter 1, We the Travellers Part 1. When was the last time you went a long trip? Where did you go? How did you travel? What was the duration of your trip? How much distance did you cover? Ask the elders who went with you to help you answer these questions. The first question is, when was the last time you went on a long trip? You can write answer by thinking. For example, your last trip was during Durga Puja. That is in October last year. Where did you go? You can write the answer by thinking. For example, suppose you went from Gujarat to West Bengal during Durga Puja. How did you travel? You might have traveled by train. What was the duration of your trip? The duration might be for train 48 hours or 2 days. As Gujarat and West Bengal are far from each other. How much distance did you cover? Approximately 2000 kilometers. Your answer might be different than that of mine. Kindly ask your elders to find the answer of these questions. Human beings have always been interested in traveling. About 100 years ago, there were far fewer vehicles than today. There were animal-driven carts, cars, and trains. Long before this, thousands of years ago, people traveled long distances on foot or used animals to travel from one place to another. They also built boats and ships to travel across lakes, rivers, and seas. Boats were probably the first form of transport invented by humans, much before bullock carts. Do you know how many vehicles are currently there in your state? You can see bullock carts here and cycles here, mostly used in the past. Reading and writing large numbers. How do you write numbers to show several thousands objects? Let us start with 1000. What numbers do we get when we keep adding 1000? 1000, 2000. Similarly, adding 1000 to it will make 3000, then 4000, 5000, 6000, 7000, 8000, 9000, and so on. What numbers do we get when we add 1000 to 9000? We get 10,000. How do we write this number? You can write 10,000 like this. Look at the table below and notice the pattern of writing numbers. In the place value chart, we have added another column, TTH. It stands for 10,000. Ones, tens, hundred, thousand, 10,000. You can see here 10 ones is equal to 110 is equal to 10. 10 tens is equal to 100, that is 100. 10 hundreds is equal to 1000, 1000. 1 when repeats 10 times makes 10. 10 repeats 10 times makes 100. 100 repeats 10 times make 1000. 1000 repeats 10 times makes 10,000. 1/10,000 is equal to 10,000 is equal to 100 hundreds is equal to 1000 tens is equal to 10,000 ones. What this means is 10,000 is equal to 10 into 1000 or 10,000 is equal to 100 into 100 or 10,000 is equal to 1000 into 10 or 10,000 is equal to 10,000 into 1. 10 into 1000 means 1000 repeating 10 times. 100 into 100 means 100 repeating 100 times. 1000 into 10 means 10 repeating 1000 times. 10,000 into 1, that means 1 repeating 10,000 times. In the same way, 10,000 is equal to 10,000 is equal to 10,000. You can represent 10,000 in words and numbers like this. We use a comma to help us read large numbers easily. You can see while writing 1000 and 10,000, I have placed comma after 3 digits from right. This makes to read the large numbers easily. 1000, 1000, 1000, 1000, 1000, repeating 10 times. 1000 plus 1000, 2000, then 3000, 4000, 5000, 6000, 7000, 8000, 9000, 10,000. That means 10 into 1000 is equal to 10,000. 1000 repeating 10 times. Do you remember how we read and write numbers in the Indian place value system? We use the same 10 digits 0 to 9 in different places to write larger numbers. For example, 1380 is equal to 1000 plus 300s plus 8 tens plus 0 ones. 1000, then 300s, then 8 tens and 0 ones. 1000, then 300, Then 8 tens when added will make 1380. Similarly, 9123 is equal to 9100, 2 tens, 3 ones. When we add 9100, 2 tens and 3 ones, we will get 9123. 9100, 2 tens and 3 ones. Let us see how we write numbers beyond 10,000 and how we name them. We write them in the same way as numbers below 9999. You can use the tokens given in the end of the book. Tokens, numbers, 10,000, thousand, hundreds, tens, ones, number name. Under tokens, you can see 1 token of 10,000 and 1 token of 1. That means 1 10,000 and 1 1 will make 10,001. 10,001. Similarly, 10,001 and 1. 1 10,000 and 2 ones will make 10,002. 10,002. Similarly, 1 10,000 token and 1 10 token will make 10,010. That is 1 10,000 and 1 10 is equal to 10,010. 1 10,000, 2 tens, 4 ones. 1 10,000, 2 tens, 4 ones will make 10,024. 10,024. 1 10,000, 3 tens, 3 ones. 1 10,000, 3 tens, 3 ones will make 10,033. 10,033. 1 10,000, 4 hundreds, 5 tens, 8 ones. 1 10,000, 0,000, 4 hundreds, 5 tens, 8 ones will make 10,458. 10,458. 10,000 and 1,000, that is 11,000. 2 hundreds, 1 10, 4 ones. That is 1 10,000, 1,000, 2 hundreds, 1 10, 4 ones will make 11,214. one 10,000, three thousands, five hundreds, two tens will make 13,520. One 10,000, three thousands, five hundreds, two tens and zero ones will make 13,520. Two 10,000 will make 20,000, that is two 10,000 will make 20,000. 10 plus 10, that is 210, is equal to 20. So, two 10,000 will make 20,000. Similarly, four 10,000s, five thousands, and eight hundreds and six tens and seven ones will make 45,867. 40,000 and 5,000, 45,000, 800s, 6 tens, that is 60, and 7 ones. 4 10,000s, 5,000s, 800s, 6 tens, and 7 ones will make 45,867. Let us do 1. Fill in the blanks by continuing the pattern in each of the following sequences. Discuss the patterns in class. A. 456, 567, 678. 456 plus 111 will make 567. Then adding 111 to it will make 678. Then adding 111 to it, similarly it will go on, will make 789. Similarly, you will get 900. Similarly, you will get 1011. And 1122. B. 1050, then gap is here, then 3150, then 4200, and so on. Between these two numbers, the gap is 4200 or 4200 minus 3150. The gap is of 1050. So subtract 1050 from 3150. You will get 2100. You will get 2100. You can check here. You can subtract 1050 from 2100. You will get 1050. So the gap between these upcoming numbers is 1050. So the next number will be 4200 plus 1050. 5250. Similarly, adding 1050 to 5250, you will get 6300. You can go on like that. You will get 7350. C 5501, 6401, 7301. What is happening here? If you subtract 5501 from 6401, you will get the difference of 900. Similarly, if you subtract 6401 from 7301, you will get a gap of 900. That means each time 900 is being added. So to get the next number, you can add 900 to 7301. You will get 8201. Similarly, on adding 900, you will get 9101. Then you will get 10,001. Then you will get 10,901. D 10,100, 10,200, 10,300. Each time 100 is being added. That means the next number will be 10,400. Similarly, 10,500, 10,600, 10,700, 10,800, 10,900. Then adding 100 to 10,900, you will get 11,000. E 10,105, 10,125. What is happening here? 20 is being added. 10,105 plus 20 is equal to 10,125. Similarly, you can add 20 to get the next number. The next number is 10,145. Then 10,165, 10,185. On adding 20 to 10,185, you will get 10,205. Then on adding 20 to it, you will get 10,225. Similarly, 10,245, 10,265, 10,285. F 10,992, 10,993, then 10,994, 10,995, 10,996, 10,997, 10,998, 10,999. On adding 1 to it, you will get 11,000. Then adding 1 to it, you will get 11,001. G 10,794, 10,796, 10,798. What is happening here? Each time 2 is being added. On adding 2 to 10,798, you will get 10,800. On adding 2 to it, you will get 10,802. Then 10,804, 10,806, 10,808, 10,810, 10,812, and so on. H 73,005, 72,004. What is happening here? Some number is being subtracted. Let's find out. Let's subtract 72,004 from 73,005. That means each time 1001 is being subtracted. So the next number will be 72,004 minus 1001. The number will be 71,003. Then subtracting 1001 from 71,003, you will get 70,002. Again subtracting 1001, you will get 69,001. $68,000, $66,999. $65,998. then you will get 64,997, 63,996. I 82,350, 83,350. What is happening here is 1000 is being added. Then here will be 84,350, 85,350 and so on. To fill in the blanks appropriately, use commas as required. Number, number name. 8045, 8045, 7209, 7209, 10,599. 10,743, 20,869, 20,869, 13,579, 10,010, 46,491, 46,491, 45,045, 39,593, 50,005, 26,050, 81,200, 90,009, 23,230, 36,001, 3. Arrange the numbers below in increasing order. You can use the number line below if required. 40,347, 34,407, 40,473, 34,740, 73,404, 74,430, 47,340, 18,926. Numbers which fall between 0 to 20,000 is 18,926. Number between 20,000 and 40,000 is 34,407, 34,740. Between 40,000 and 60,000, 40,350, 40,347, 40,473, 47,340. And the numbers between 60,000 and 80,000 is 73,404, 74,430. I am writing here. You can write here. So you can write the numbers in ascending order like this. 4. A student said 9,990 is greater than 49,014 because 9 is greater than 4. Is the student correct? Why or why not? You have to compare 1 to 1s, then tens to tens, hundreds to hundreds, then thousands to thousands, and 10,000s to 10,000s. Since the first number has 9,000, which is much less than 49,000, so the first number is less than the second number. So the student was incorrect. Use the number line below to find the position of the number. Fill in the blanks. 5,000, 10,000. If this is 5,000 and this is 10,000, then here will be 15,000, 20,000, 25,000, 30,000, 35,000, 40,000, 45,000, and 50,000, and so on. You can use this place value chart to compare the numbers. For the above question, you can use this place value chart to compare. You can see the first number has 9 thousands, while the second number has 4 10,000s and 9 9,000s. That will make 49,000, which is much larger than 9,000. So the first number is smaller. 5. Digit swap. A. In the number 1478, interchanging the digits 7 and 4 gives 1748. Now, interchange any two digits in the number 1478 to make a number that is larger than 5500. You have to interchange two digits from the number 1478 to make a number larger than 5500. You may either start with 7 or 8. That is, you have to interchange 7 with 1. That means the new number will be 7418. If you interchange 8 with 1, the number will be 8471. So there could be two answers. B. Interchange two digits of 10,593 to make a number 1 between 11,000 and 15,000. 2. More than 35,000. To make a number between 11,000 and 15,000, you have to interchange two digits of the number 10,593. You can make a number starting with 13,000. For this, you have to interchange 0 and 3. So the new number will be 13,590. To make a number that is more than 35,000, you have to start with 5 or 9. That means you have to interchange 5 and 1 or 9 and 1. The new number will be 50,193 or 90,513. I have interchanged 5 and 1 for this number and 9 and 1 for this number in 10,593. C. Interchange two digits of 40,247 to make a number 1 as small as possible. To make a number as small as possible, you have to start with smallest number, that is 2. Then you can repeat 4 and 4 as there are two 4s. Then 7 and 8. The new number, that is the smallest one, is 24,478. 2. As big as possible. For this you have to start with largest number, that is 8. The largest number will be 87,442. Nearest tens, hundreds and thousands. A rabbit is hungry. Its location is given in the pictures below. Its food has been kept at two places. Help the rabbit to reach its food. The rabbit is at 2346. Its food has been kept at its neighboring tens. On which tens should the rabbit go to get its food with the least number of steps? You can see the rabbit is at 2346. The nearest number, that is multiple of 10, to the rabbit is 2350. You have to add 4 to get 2350. Similarly, if rabbit have returned to 2340, then he have to move 6 steps backwards. So 2350 is the nearest 10 of 2346. It will need 4 jumps to reach 2350. The rabbit is at 2346. Its food has been kept at its neighboring hundreds. Which of the two hundreds should the rabbit go? The difference between 2400 and 2346 is of 54, and the difference between 2346 and 2300 is of 46. So the nearest 100 is 2300 as 46 is smaller than 54. You can see between 2300 and 2400 there is 2350. Since the rabbit is between 2350 and 2300, the nearest 100 will be 2300. 2300 is the nearest 100 of 2346. It will need 46 jumps to reach 2300. The rabbit is at 2346. Its food has been kept at its neighboring thousands. Which number should the rabbit go to? Between 2000 and 3000 you can see 2500. Since rabbit is between 2000 and 2500, so rabbit must go to nearest thousand, that is 2000. The number of steps required is 2346 minus 2000, that is 346. 2000 is the nearest thousand of 2346. It will need 346 jumps to reach 2000. Fill in the boxes appropriately. Number, nearest tens, nearest hundreds, nearest thousands. 3176. Nearest tens is 3180. Nearest hundreds is 3200. And nearest thousands is 3000. 4017. Nearest tens is 4020. Nearest hundred is 4000. Nearest thousands is 4000. 5789. Nearest tens is 5790. Nearest hundreds is 5800. Nearest thousand is 6000. 8203. Nearest tens is 8200. Nearest hundreds is 8200 again, and nearest thousand is 8000. Let us think. 1. Vijay rounded off a number to the nearest hundred. Suma rounded off the same number to the nearest thousand. Both got the same result. Circle the numbers they might have used. Let's find nearest hundreds and nearest thousands of the given numbers. Nearest hundred, nearest thousand for the first number, for the second one, for the third one, and the for fourth one. You can see nearest thousand and nearest hundreds are same for last two numbers, that is 7030 and 6999. The answer is 7030 and 6999. Note to the teacher. Help the learners notice the placement of the numbers in the neighboring range of tens, hundreds and thousands. Encourage them to use such images till they get comfortable identifying the nearest 10, 100 and 1000. 2. Think and write two numbers that have the same A. Nearest 10, B. Nearest 100, C. Nearest 1000. For example, 19 and 21 have the same nearest 10, that is 20. You have to write similar numbers having nearest tens. For example, for the first one, you can write 78 and 83. Both have nearest 10 same, that is 80. For nearest 100, you can write 281 and 319. Both has same nearest 100, that is 300. Similarly, nearest 1000, you can write 5179 and 4862, like that. For these questions, your answers may be different than mine. Somebody may write like this. For A, nearest 10 same. For the second one, that is nearest 100 same. For the third one, nearest 1000 same. In A, nearest 10 that is same is 3480. For B, nearest 100 same, that is 3500. And for C, nearest 1000 same, that is 3000. 3. Think and write the numbers that have the same A, nearest tens and nearest 100. B, nearest 100 and nearest 1000. C, nearest 10, 100 and 1000. For same nearest 10 and nearest 100, you can write like this. Both have same nearest 10 and hundreds, that is 4300. For same nearest hundred and nearest thousand, you can write like this. Nearest hundred and nearest thousand of these numbers is 4000. Nearest tens, hundreds and thousands. You can write like this. Numbers like these. All having same nearest 10, 100 and 1000. That is 4000. Traveling now and then. We learned that people in the past traveled on foot, on animals, and used boats and sailing ships. The animals that have been used for traveling include bullocks, horses, donkeys, mules, and elephants. In hilly and snowy covered regions, yaks, dogs, and reindeers have been used, while camels have been used in deserts. Now, people use bicycles, motorbikes, cars, buses, trains, ships, and aeroplanes to travel from one place to another. Submarines are used to go deep underwater. Humans are also using spacecraft to travel to outer space. You can see different modes of transports such as ships, aeroplane, motorbikes, train, bus, dog-driven carts, spacecraft, and submarines. In an hour, a person can generally travel A. 3 to 5 km on foot, B. 10 to 15 km on horseback, C. 12 to 20 km by cycle, D. 40 to 60 km by motorbike, E. 40 to 160 km by train, F. 20 to 45 km by ship, G. 750 to 920 km by aircraft, H. minimum 2800 km by spacecraft. Let us do 1. A cyclist can cover 15 km in 1 hour. How much distance will she cover in 4 hours if she maintains the same speed? In 1 hour, she covers 15 km. In 2 hours, she will cover 30 km, that is double of 15. In 3 hours, she will cover 45 km, that is triple of 15. And in 4 hours, she will cover 60 kilometers, that is 4 times of 15. You can use the formula distance is equal to speed into time. Speed is equal to 15 km in 1 hour and time is 4 hours. 15 into 4 is equal to 60. 60 km. 2. A school has 461 girls and 439 boys. How many vehicles are needed for all of them to go on a trip using the following modes of travel? The number in the bracket indicates the number of people that can travel in one vehicle. A bicycle. Total number of children here 461 girls, 439 boys. When added, you will get 900. Number of children here is 900. If a bicycle can carry 2 children, then number of bicycles required is 900 upon 2. That is 450 bicycle. Similarly, B auto rickshaw. When you will divide 900 by 3, you will get 300. C car. When you will divide 900 by 4, you will get 225. D big car carrying 6 children. That is 900 upon 6. That is equal to 150. E tempo traveler carrying 10 children each. 900 upon 10 is equal to 90. Boat 900 upon 20 is equal to 45. G minibus 900 upon 25 is equal to 9 into 4 is equal to 36. H aeroplane, that is 900 upon 185. Finding large numbers around us. We saw that the distance in kilometer covered by different means of transport in an hour can range from a 1-digit number to a 5-digit number. Can we find other contexts around us that contain numbers in this range? Let us consider the situation below. A book has around 200 pages and each page has about 50 words. The book therefore has about 10,000 words in all. Find something in the textbook whose count is a 4-digit number. Now let us try this with our school. A. Our school has dash classrooms. For example, I am writing here 50. B. There are dash students in my class. I am writing here 40. C. Our classroom has dash books in total. Suppose one child brings 7 books, then 40 child will bring 40 into 7, that is 280 books. Usually, we measure distances in sea and air using nautical miles. For now, we will use 1 kilometer is equal to 1000 meter. By now, you know different units of measuring length. We will study the units for measuring length, that is kilometer, in detail in a later chapter. Find something in the classroom whose count is a 4-digit number. You can write number of pages in textbook of mathematics in my classroom. There are 40 students in your class and your math textbook has 200 pages. That means number of pages in total is equal to 8000, which is a 4-digit number. 2. 5-digit number. Suppose the number of books brought by each child is 7. Then number of pages of books in whole classroom is 8000 into 7. That is 56,000, which is a 5-digit number. For the first one, you can write the answer like this. Number of pages in the maths textbook of all students in a class. And for the second one, you can write like this. Number of pages in all the textbook of all students in a class. List some quantities whose count is a 4-digit number or a 5-digit number in the context of 1. A tree, 2. Your village, town, city, or any other place of your choice. I am taking a big tree. It may have a number of leaves in 4 digits or 5 digit. If it has 8000 leaves, then it will have 4 digits, and if it has more than 10,000, then it will have 5-digit numbers related to it. Your village, town, city, or any other place of your choice. For second one, number of people in a district or a city may be of 4 digit or 5 digit. For example, there may be 9,000 people. Then it is of 4 digit. Similarly, there may be 7,800 people. That is a 5-digit number. Pastime mathematics. Sanju and Meera are traveling on a train. To pass time, they challenge each other with games and puzzles. 1. Meera poses the river crossing puzzle to Sanju. A boatman wants to cross a river in a boat. He had to take a loin, a ship, and a bundle of grass with him. He can take one of them at a time. If the sheep and grass are left on the shore, the sheep will eat the grass. And if the sheep and the loin are left on the shore, the loin will eat the sheep. How can the boatman take the loin, sheep, and grass across the river? Help him so that he can ferry the loin, sheep, and grass across the river safely and in the minimum number of trips. You can see here grass, loin, and sheep. Boatman has to carry these to other side of the river.
At a time, he can take only one of them. Suppose he takes grass, then lion will eat the sheep. If he takes lion, then sheep will eat grass. But if he takes the sheep, then lion can't eat the grass. So the correct answer is he should take the sheep first. 2. Sanju introduces a game called Pile of Pebbles to Mira. There are two piles of pebbles. Each pile contains 7 pebbles. Each player can pick as many pebbles they want from either of the piles. The player who picks the last pebble wins. Try this game with your friends. Now, how do you play so that you win? The strategy of winning is simple. If first player picks 4 piles, then you have to pick same number of piles from the second stack. If first player take 2 piles from first stack, then you have to pick same number of piles from the second stack. Then he will pick 1 pile from the first stack. Then you can pick the last pile and win the game. The strategy is simple. You have to pick the same number of piles as the opponent, or while in between you have to make the height of the two stacks same. That means same number of piles here and here after your turn. To find a winning strategy, try playing with one pebble in each pile, 2 in each, 3 in each, and so on. 3. Now it's Mira's turn. She gives a fun puzzle to Sanju with the following steps. A. Take any two different digits. For example, 3 and 7. B. Make two-digit numbers using them. You can make 37 and 73. C. Subtract the smaller number from the bigger number. You have to subtract 37 from 73. You will get 36. Now use the two digits in the difference and repeat steps B and C. For example, if you take different numbers such as 1 and 9, you can make two numbers of two digits, that is 19 and 91. Difference between them is 91 minus 19 is 72. Continue this process until you get a one-digit number. Even before everyone could finish, Mira exclaimed, "Mind you, no matter which numbers you choose, you will get 9 in the end." Okay, you have to continue this journey till you get one digit number. The whole process will look as shown below. For the given example, you have taken 3 and 7, you have made numbers 37 and 73. Difference is 36. 36 is made of two digits, 3 and 6. You can make 63 from 36 by reversing it, by swapping the digits. Difference is 27. From 27, you can make 72. Difference between 72 and 27 is 45. On reversing the digits of 45, you will get 54. Difference between 54 and 45 is 9. 9 is a one-digit number. How did Mira know what the one-digit number in the end would be? You can observe the difference 36, 27, 45 and 9. These all numbers are multiple of 9. Since 9 is a one-digit number, the answer would be 9. For my example, that is 1 and 9. The difference between 91 and 19 is 72. On reversing 72, you will get 27. Difference is 45. On reversing 45, you will get 54. Difference between 54 and 45 is 9. 9 is a one-digit number. Let us explore. 1. Observe the differences you get in each step above. Do you notice anything in common? Yes, all the numbers or differences obtained are multiple of 9. You can write like this. All the differences are multiple of 9. 2. Try the puzzle using any other pair of digits. What is the common to these differences? What do you get in the end? The answer is same. All the differences are multiple of 9 and at the end you will get one digit number, that is 9. 3. What digits can you choose so that you get a one digit number in the first step itself? Give some examples. Describe the pattern in the digits. You can see here, if you have taken 4 and 5, you would have got 9 in the first turn. Note for teachers. Encourage the students to think logically and strategically while solving these puzzles. Such thinking underlines all of mathematics. 4. Now find different digits such that the difference between the numbers is 27. You can see difference between 63 and 36 is 27. So you can take digits 3 and 6. From 3 and 6 you can make two numbers 63 and 36. Difference between them is 27. 5. Meera found an interesting relationship between the two digits and the difference obtained. Can you see it in the table that Meera made? Digits, differences in digits, difference in the number found by the digits. Digits 3 and 7, differences in digits is equal to 4 and differences in the numbers formed by the digits is 36. You can see 36 is 4 times 9. If you had taken digits 1 and 9, the difference will be 8 and difference between two digit numbers formed is 72. 72 is 8 times 9. If you had taken 2 and 8, the difference between digits is 6 and difference between the two digit numbers formed is 54. 54 is 6 times 9. Similarly, if you have taken 4 and 5, difference between the digit is 1. Difference between the two digit number formed is 9. 9 is 1 times 9. Extend this table by choosing the appropriate digits so that the resulting differences are 2, 3, 5 and 7 respectively. If you want difference of 2, you can take digits such as 2 and 4. Difference between digits will be 4 minus 2 is equal to 2 and difference between two numbers formed is 42 minus 24, that is 18. Similarly, if you want difference of 3, you can take 2 and 5. Difference between digits is 5 minus 2 is equal to 3, and difference between two digit number formed is 52 minus 25 is equal to 27. Similarly, for 5, you can take 3 and 8. Difference between digits is 8 minus 3 is equal to 5. Difference between two digit number formed is 83 minus 38 is equal to 45. For 7, you can take 2 and 9. Difference between 9 and 2 is 7. Difference between two digit number formed is 92 minus 29 is equal to 63. What do the difference between the digits indicate? The difference between the digits indicate that when these digits are multiplied by 9, you will get the difference of the two digit number formed. 9 times 5 is equal to 45, 9 times 7 is equal to 63. List the numbers that give one digit number in the third subtraction. For this, you can take 3 and 0. Difference between 30 and 3 is 27. Difference between 72 and 27 is 45. Difference between 54 and 45 is 9. First subtraction, second and the third one, giving one digit number 9. Identify the pairs of digits that lead to the one digit number after the maximum possible number of subtraction. Compare your answers with your friends. If you take digits such as 0 and 9, you have to repeat 5 times the steps given to get one digit number 9. Like this. First step, 90 minus 9 is equal to 81. Second step, 81 minus 18 is equal to 63. Third step, 63 minus 36 is equal to 27. Fourth step, 72 minus 27 is equal to 45. And in the fifth step, 54 minus 45, you will get one digit number 9. Maximum possible number of subtraction is 5. Let us do 1. Write 5 numbers between the numbers 23,568 and 24,234. You can write like this: 23,658, 23,685, 23,856, 23,865, 23,586. Like that. 2. Write 5 numbers that are more than 38,125 but less than 38,600. You can write like this: 38,500, 38,550, 38,200, 38,367, 38,459, like that. 3. Ravi's car has been driven for 56,987 km till now. Sheetal's car has been driven 67,543 km. Whose car has been driven more? Comparing 100,000 and 10,000 like this. Ones, tens, 100,000, 10,000. You can see 6 is more than 5. So 67,000 will be more than 56. So overall 67,543 is more. The answer will be Sheetal's car. 4. The following are the prices of different electric bikes. Arrange the prices in ascending or increasing order. Comparing 10,000, 39,000, 49,000, then 89,000, then 90,000, then 93,000, then 94,000. First, second, then this one will be third, then fourth, fifth, and the last one sixth. You can write in ascending order like this. Five. The following table shows the population of some towns. Arrange them in a descending or decreasing order. You can see town and population. You have to arrange the population of towns in decreasing order. Comparing 10,000. The largest one is 66,000. Smaller than this is 65,000. Then 56,000. Then 53,000. 51. 45. That means town 6, town 1, then town 3, town 2, town 4, and the last one town 5 in decreasing or descending order. 6. Find numbers between 42,750 and 53,500 such that the ones, tens, and hundreds digits are all 0. You can write 43,000, 44,000, 45,000, and so on like this. 52,000, 53,000. All these numbers has ones, tens, and hundred digits 0. 7. Write the following numbers in the expanded form. 1 has been done for you. A 783. 700 plus 80 plus 3. B 8062. 8000 plus 60 plus 2. C 9980. 9000 plus 900 plus 80. D 10304. 10,000 plus 300 plus 4. E 23,004. 20,000 plus 3,000 plus 4. F 70,405. 70,000 plus 400 plus 5. 8. Fill in the blanks with the correct answer. Share your thoughts in class. A 983. 90 tens plus 83 ones. 90 tens means 900. 83 ones means 80 and 3 ones. Ninety tens is 900, so remaining 83 will be ones. B 68 is equal to dash tens and 18 ones. If you subtract 18 ones from 68, you will get 50. 50 is 5 tens. That is 5 tens and 18 ones will make 68. C 607. 4 hundreds plus dash ones. If you subtract 400 from 607, you will get 207. That means 207 ones. D 5621. 4000 plus dash hundreds plus 2 tens plus dash ones. You can split 5621 like this. 4000 plus 2 tens, that means 20, and ones is 1. To complete this, you have to write 16 hundreds like this. That means 4000 plus 16 hundreds plus 2 tens and 1 ones will make 5621. E 7069 dash thousand plus 20 hundreds plus dash ones. 20 hundreds means 2000. You can subtract 2000 from 7069. You will get 5069. 5069 has 5000 and 69 ones. F 37608 is equal to dash 10,000 plus 17,000 plus dash 100 plus 8 ones. You can subtract 17,000 and 8 ones. 17,000 when subtracted from 37,608, you can subtract 17,008. You will get 20,600. 20,600 can be splitted in two 10,000 and 600s, two 10,000s and 600s. G 43,001, three 10,000 that is 30,000 plus 10,000 will make 40,000 and then 30 hundreds that is 3,000 and ones. You can add and get 43,001, 30,000, 10,000, 30 hundred means 3,000 and 1. When added, you will get 43,001. 9. Fill in the blanks with the correct answers. A. How many notes of rupees 10 are there in 7,934? If you round 7,934 in multiple of 10, the nearest 10 is 7,930, which is equal to 793 multiplied by 10. That means 793 rupees 10 notes. 3 tens is 30, 90 tens is 900 and 700 tens is equal to 7,000. B. How many notes of rupees 100 are there in 7,934? Rounding off the given number to nearest 100 that is less than it, you will get 7,900. So you can write 79 into 100. That means 7,900 notes. See how many thousands are there in 7,934. Nearest thousand that is less than this number is 7,000, not 8,000. 8,000 is more than this. D. How many rupees 500 notes are there in 7,934? You already know 7,934 has 7,000 rupees notes. That means 14 rupees 500 notes. It will make 7,000, but the given number is larger than this. You can add another rupees 500 note to it. You will get 7,500. If you add another rupees 500 to it, you will get 8,000, which is more than the given number. So 14 and 1, 15. So 15 rupees 500 notes will be nearer to rupees 7,934. You can check like this. 15 into 500, you will get 7,500. If you subtract 7,500 from 7,934, you will get 434, which is less than rupees 500. Hint: observe the answer of 3. A. How many notes of rupees 10 are there in 65,342? Nearest 10 that is less than this number is 65,340. That is 6,534 multiplied to 10. The answer is 6,534. F. How many notes of rupees 100 are there in 65,342? Nearest 100 that is less than this number is 65,300, which is equal to 653 multiplied to 100. The answer is 653. G. How many thousands are there in 65,342? Nearest thousand to this number is, that is less than this, 65,000. That means 65,000 rupees note are there in rupees 65,342. H. How many rupees 500 notes are there in rupees 65,342? You already know there are 65,000 rupees notes, and in 1000 there are two 500 rupees note. That means there could be 130 500 rupees note. If you multiply 132 rupees 500, you will get 65,000. And if you subtract 65,000 from the given number, you can see you are getting 342, which is less than 500. So no other note of rupees 500 can be added. The answer is 130. King's horses. Once upon a time there was a king who was very fond of horses. He had 20 horses of the best breed. The horses were kept in the royal stable and cared for by a caretaker. One night, a thief stole one of the horses. Fearing punishment, the caretaker arranged the horses in the stable as shown in the picture here. You can see the dots above show how the horses were arranged in the stable. Number of horses here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. One horse is missing. The next day, when the king came to check on the horses, the caretaker led him around the square stable. Please count the number of horses along each side, Your Majesty, he said. The king counted 5 horses along each side. We have 5 horses along each side, and there are 4 sides. So there are a total of 20 horses, Your Majesty, the caretaker explained. Satisfied with the explanation, the king returned to his palace. But wait, were there really 20 horses in the stable? Count the horses one by one and check. What was the mistake in the caretaker's explanation? The following night, the thief stole another horse from the stable. Now, only 18 horses remained. The caretaker once again cleverly arranged 18 horses so that there were 5 horses on each side of the square stable. How do you think he was able to do it? Arrange the 18 horses in the stable with 5 on each side. How many more horses can the thief steal before the king notices something is wrong? Try making the arrangements yourself. In the first case, when one horse is stolen, you can see from each side. When seen, you can see 5 horses. And in the explanation, the caretaker told the king that 5 multiplied to 4 is 20. But one more horse has been stolen and 18 horses are there. So you have to arrange 18 horses such that when seen from each side, the total number of horses looks to be 20. That means 5 multiplied to 4. You can see here how the arrangement has been made. Suppose this horse is not here. Then you can move this horse to this place such that 5 horses are there on each side. And when 5 multiplied to 4, you will get 20. The arrangement should be like this. You can make this arrangement here. Like this. You can see 5, 5, 5 and 5 here. It has been asked what is the minimum number of horses there should be such that each side has 5 horses such that 5 multiplied to 4 gives 20. So that king doesn't come to know that horses are being stolen. You can make arrangements like this. Like this. You can see on each side there are 5 horses. But this is not the correct answer. Suppose you want to remove horses or move horses from these places. You can place them here and here. You can see 5 horses on each side. Minimum number of horses present here in this case is 3 plus 3 plus 2 plus 2. That means 10. Maximum number of horses that can be stolen is 10. That is 20 minus 10 is equal to 10. The remaining 10 horses can be arranged in this way. For more videos, you can like and subscribe at Ncert Video Books. If you have any doubt, then you can comment below. Thank you.